In this circuit diagram, we need to use the node voltage method to find V subscript A ohms, V subscript 4 ohms, and I subscript 1 for amps. And this is the current flowing through the 6 ohm resistor. I gave an example down here. This is from the notes that are linked below that has a bunch of formulas and stuff in it that'll help with this problem, as well as steps. These steps are specifically designed for this problem. However, we can use them for any node voltage method with dependent sources problem. The reason why this is dependent sources is because, yes, we have a node voltage here and node voltage here, but we also have this unknown voltage. Our first node is going to be this one right here. Our second node is going to be this one right here. We're going to write them as V8 ohms and this one as V4 ohms. And based on this right here, we can write that we have the plus end like this and the minus end like this. Same thing for this resistor, we have the plus and the minus. And we know that our voltage goes this way, so it goes out of our node. It's important to note the direction because that will matter with our signs. When we're first starting to look at this, I'm going to look at step 2 because we've already done step 1, we've defined our variables. So at node 1, we have our V1 minus our voltage source over the resistor between them. So our V1 is going to be the V8 ohms. So we can write V8 ohms like this, and this is going to be subtracted from our voltage source. And that is because our voltage source is going into this node, and it's in series like this. Because if we were to combine this entire right side, all of the resistors for this right side, it would be in this 8 ohm resistor part. So we just have the 6 ohms and 8 ohms right here, and the current would just flow like this through it. Since it's like that, we have to subtract from it, so we're going to have a minus 50 volts, and this all takes place over the 6 ohm resistor. Next, we have our plus V1 over R1. Our V1 again is basically just V8 ohms over our resistance for it, which is 8 ohms. Next, we're going to look at the current for this side, and how we do that is we take the V2, subtract it from the V1, and the resistor between them, which is 2 ohms, and we're setting this equal to 0. So that is how you do this first part. In our next node, we have current going in like this. It's going to be V2 minus our V1. V1 is the current going in, and then this is all happening over the 2 ohm resistor. Then we can have a plus like this, and we want to look at the second part now. So we're going to do V4 ohms over 4 ohms. I mislabeled this because of habit. This V2 should be V4 ohms, and this V1 should be V8 ohms. Same thing for up here as well. These should be replaced. And we have the second part because it's going down here. And then we have this amperage going into our node. Since it's going into our node, it's going to be a minus 5 amps because of Kirchhoff's current law. And this is set equal to 0. I did forget something though. It is important to remember that we have this that's connected to our circuit. And so when we look at the first node, all the problems that we've done so far have only involved 3 parts, just like this. Well, this is going to involve the fourth part. I'm going to draw this in red. This 3 amp current is going to be flowing through here and into our node. Since it's flowing into our node, it's going to be a minus. So we can just move this over and write a minus 3I1. And then we know that this is basically voltage. So we're going to have 3I1 volts equal to 0. And this part will be moved over as well because this is going out of this node and it's going this way. Since it's going out, it's going to be a plus, and then it's a plus 3I1, and this is in volts, equal to 0. Our third unknown is this I1, so we need to find it. It is the dependent variable, so we are going to look at the dependent variation of the formula for it. And this variation, we have our I0 equal to a V1 minus V2 over the resistance between them. Well, our I1 is right here. So the first thing that we're going to change is this. So it's instead of I0, it's I1. The resistance in between them is a 6 ohm resistor, and the voltage 1 is actually a voltage 8 ohms. And then our V2, part that's being subtracted, is the 50 voltage. So this is our I1 formula. Next, we're going to simplify and combine like terms. For this one, we are going to multiply everything by 24 ohms. This one, we are going to multiply everything by 4 ohms. Once we've done all that, we are going to get this equation and this equation right here. From here, I can also rewrite our bottom equation to be subscript 8 ohms minus 50 volts minus 6 times I1 ohms. We're not actually going to do anything with this, but we can use it to see that we have no V subscript 4 ohms in it. So that means if we cancel out the V subscript 4 ohms somehow and add these two together, we only have the two unknowns and we can just substitute for one of them. So that's exactly what I'm going to do. I'm going to multiply this whole bottom equation by 4. If we do that, we are going to get these equations, and now we can add them together. We can cancel out these two, and then from here we are going to get an 11 V8 subscript ohms plus a negative 24 I1 V times ohms, and this is equal to 280 volts. So this is our new equation right here. And now I'm just going to plug in our I1 for our I1 that's in this part right here. If I do this, I'm going to get an 11 V8 ohms plus our negative 24, and we will move the volts times ohms out front. And then I'm also going to move the 6 ohms out front from our equation that we're putting in. And then in parentheses, we have a V8 ohms minus 50 volts. And this is going to be set equal to 280 volts. From here, all we're going to do is combine like terms. First, I'm going to get rid of this ohms right here. So we have V as our only unit. Then I'll get rid of this. We'll have 4 here. And then we'll multiply this in. And then we're going to get this. So we're just going to combine like terms. We'll have a 15 V8 ohms, and that's equal to 480 volts. And if we divide this out, we're going to get that our V8 ohms is equal to 32 volts. And this is the answer for our first part. Now that we have this, we could just plug into things that we know. I'm going to plug into this equation right here because all it's missing is the V8 ohms, and we just found that. And I'm going to do this up here where I have our I1, setting this equal to our 32 volts up top minus the 50 volts. And this is going to be over our 6 ohms. We know voltage over ohms is amps. So all we have to do is subtract these two. However, I did make this mistake. If we do this, we're going to get that I1 is equal to a negative 3 amps. My mistake is that there is a negative right here, and there shouldn't be because I actually looked at this incorrectly. When we have our I1 equal to these two things, we don't want to be subtracting our 50 volts from this V8 ohms right here. We want to do it the other way around. We want to have 50 out front. So this is 50 volts and this is V8 ohms right here. And the reason why this is because even if we look down here at the instructions, we have our V1 minus V2. Normally our V1's right here and our V2's right here. So this is V1 and this is V2. However, if we switch things around, we're moving both of these over. This is going to be our new V1 and this is going to be our V2. That's why our V1 has to be 50 volts and then our V2 is V8 ohms. That doesn't change anything for this problem really until this step that I just got on here. However, if we had to use this, it would probably make some other errors. So I'm going to go back to the right over here, make this a negative and this a positive. So this should be a positive 3 amps. So we have a 3 amps for this answer. Lastly, we just have to plug both of these values in and find our V4 ohms. We'll do this down here, and we can use any equation we want. I'm just going to use this equation right here. We have our negative 2, and this is being multiplied by the voltage we found to be 32, plus our 3, and then I'm going to get a little bit loose with the units here, but it's important to normally keep them. I'm just going to call this V4, and this is a plus 12 times our I, which is 3, set equal to 20. So if we combine these, we're going to get a negative 64. And if we combine these, we're going to get a 36. So if we have negative 64 plus 36, we're going to get a negative 28. Then we could bring this down plus 3V4, and that's equal to 20. If we add 28 to the sides, we get V4 is equal to 48. And if we divide both sides by 3, we get V4 is equal to 16 volts. That is the answer right here. So that is how you do this problem. It got a little bit messy at the end because of how big it was, but that is the way to look at this circuit diagram. If you want more examples like this, there is a playlist linked below, as well as notes that would help with this or study for exams.